Good day to everyone. This will be our discussions involving business hardware or still the course management information systems. For hardware components, so basically these are the computer parts that are tangible in nature as opposed to intangible that will be tackled in business software. Now, for the objectives or outcomes of this particular session, we should be able to list the components of major hardware and then explain their functions. Second, classify computers into major categories and identify their strengths and weaknesses. Then, if ever we decide to purchase certain computers, we need to know and evaluate key criteria for deciding. Next would be discuss the possible health hazards of computer use. All right, so let's discuss first what hardware is or what hardware are. Physical components of computers and related electronic devices. Take note of the word physical, and that is our clue. We said a while ago tangible, which can be perceived by our senses. Then we need to consider software first before hardware. This is very important because whatever would be the requirements for our computer, then we are going to adjust our hardware components from there. Computer must handle 4 operations: to accept data, to store the data and instructions, process such, and the output. So basically, we're talking about input, storage, process, and output. So normally these are the 4 key areas or operations of a system and the computer. Now, in general, every computer has the following components: the input devices, the CPU, which is found inside the systems unit, which is that big black box, normally that we can see, not the black box that we know of in other fields or areas like components of airplanes, but we're talking about that part of the computer that we can see, a literal big black box in which the CPU is inside it. We call that the systems unit, by the way. Internal memory, the storage, and the output devices. Input devices would receive signals from outside of computer and transfer them into the computer. So basically, these are the items on the entry levels. They would be detecting certain items from the outside and will be placing them inside the system. Now, here are our basic components of computers. We have, as what we said a while ago, the input, the storage, the output, the CPU for our computer inside, including our internal memory items, the random access memory, the RAM and ROM chips. For the storage, we have our hard disk and the CD/DVD drive. So storage to begin with: input, output, storage, and then output devices. Well, they've actually been seen there: the printer, the screen or the monitor, and the speakers. Input would be our respective keyboard, the mouse, the microphone, and the joystick, if that is applicable, or the pen, if you would like that. Storage, we've said a while ago, including the internal memory and the CPU. So CPU would be for the processing. It is called the central processing unit. It's like the brain of human beings, wherein it would process all data and information, and action will be made or actions will be done depending on the instructions given by the user. CPU accepts instructions and data, decodes and executes instructions, and stores results or output in the memory. We have again the internal or primary memory, which would store the data and instructions before and after CPU processes them. So basically, they are like the points prior to our RAM and ROM. So RAM stands for random access memory. I've mentioned that a while ago. While ROM, I did not, but it means read-only memory. Then the motherboard is the circuit board containing the CPU and primary memory. So basically, these are the technical terms on parts of the computer. Storage would be the items where we can keep or store our information, like the magnetic disks, magnetic tapes, optical disks, DVDs, and the flash memory drives, in which the normal terms that we call of the flash memories would be the USBs. But basically, just to clarify, USBs are the storage, for example, facility in which we can basically place a certain item there. So we can place a word after that and it changes the meaning. So if we say USB port, that's the port or that's the point of entry that we can place a cord, the USB cord that can be connected. And that also USB port, we can place certain devices like flash memory drives. Again, the usual term that we use of such would be the USBs. So it's called flash memory drive, or they're called flash memory drives because basically such flashes or they flash. So literal interpretation of that. And this allows permanent storage. Output devices would be showing the information from the computer to the user. The common ones would be the monitors and printers. And then even microphones can, of course, be input. In that sense, some would be confusing that as output, but the speakers would be the output. So would be producing the voice that we are recording. Then another one would be the binary digit 0 or 1. This can be for already those who are really into IT and computer engineering. But anyway, byte is a standard group of 8 bits or 8 number or like 8 bits to be more specific. Most characters can be represented by a single byte. Computer memory and storage capacity are measured in these bytes, whether mega, giga, or tera. Then here are our conversions. So we don't have to memorize, but we can somehow check that there can be as many bytes as possible. A byte is composed of 8 bits. So all we have to do for conversion purposes is to multiply each to 8 to become bits. So we can see that from this particular slide. Then kilo is 1,000, mega is million, giga is billion, and tera would be trillion, peta would be quadrillion, exa would be pentillion. Yeah, we can check that one. Then classification of computers for this one would be depending on the size and power. Power is determined mainly by processing speed and memory size. And the more power there are, the more expensive the computer becomes. And if we are now in the modern age or world, sometimes the power of the computers does not necessarily correlate with the size of the computer. So even with as little as a thin laptop, it can actually process a lot, and it has already a big storage capacity as compared than before. Anyway, so even within 6 months, that's the usual or the minimum number of time. It can be less or more, or exactly a year or more, but then there can be updates on operating systems and operating capabilities. Now, supercomputers are the most powerful computers at any given time. They're the largest in physical size, and as what we've said, the larger they are, the more expensive they are. So in fact, supercomputers are the largest and most expensive, designed for complex arithmetic calculations and generally impractical for business purposes because they are very big. In fact, if we are going to look back the history of computers, we can check that the very first computers actually are very big, like a lot of rooms. Or if you are going to compare such to classrooms, there are so many of rooms constituting that particular computer. Next would be the parallel processing. So multiple processors running simultaneously. And this is also known as multiprocessing. Now in today's world, like the computers that we have, we can do actually multiprocessing, that we are, for example, opening Microsoft Word at the same time we're listening to music, at the same time we are loading a lot of browsers and all. Then mainframe computers store large amounts of data and business transactions. They're less expensive, less powerful. These are the ones used by banks, universities, and insurance companies as a central computer. 40 to 50% of world's business data resides on mainframes, and we use multiple processors. This is now going down in terms of cost and power as compared to supercomputers. Mid-range computers act as servers within organizations or through the internet. If supercomputers can perform the complex calculations, but then it's not that practical for business, mainframe, it's practical, it can store large and can process business transactions. With that, even if it's less powerful, but it is used, then mid-range would act now as the connection of our mainframe to other computers, act as servers within organizations or through the internet. Smaller and less powerful than mainframes serve hundreds of users that connect from personal computers because, again, such can act as servers and still can use multiple processors or can do multiprocessing. Now, microcomputers are the ones used personally by users. Personal computers or PCs, the notebooks, and the handhelds, and even the laptops. Workstation, more powerful microcomputer used for CAD or computer-aided design, computer-aided manufacturing, and scientific applications. Now, the power of microcomputers, as what we've mentioned a while ago, doubles about every 2 years, but this one is from this particular time of this source. So compare that today, 2021, for sure, it can even double in a lesser amount of time, not just 2 years. Then computers on the go, we have notebook or laptop, compact personal computer powered by rechargeable battery. Then new models include wireless technology. We don't have to make use of the cable. We can, of course, connect through the Wi-Fi. Next is PDA or personal digital assistant, a handheld computer like stylus, pen-like device used to enter data through a touch screen. If the screen or monitor of our respective computer is actually available for the usage of stylus or even hands, just like if we have our tab or device, iPad, for example, wherein we can use our fingers to input something, not necessarily the pen-like device. But for this one, this is stylus. The concept is the same anyway. Tablet computer is PC in the form of a thick writing tablet. I've mentioned about the tab that recognizes handwriting, so with the use of our fingertips. This one is interesting. Technology convergence, building several technologies into a single piece of hardware. Example would be for handheld units, which are very prominent or which are very relevant and common nowadays. Examples would be cell phones. So there can be a lot of processes that can be used using cell phones. We can use that calling, messaging, for video chatting, for using of the apps, for browsing the net, etc. Television nowadays also are capable of being powered by internet. So we can like connect that to our internet and utilize such for same way as our viewing through computers. Digital cameras, digital sound recorders, and our MP3 player. So because of technologies being converged or combined, then we are able to produce these particular hardwares. Then if we look inside the computer, professionals must know about computer components to understand their power and capabilities. So example, there is a case or situation. So what can be used? What hardware should be used in that case? Then this knowledge will be used in making good decisions in purchasing or recommending the best computer for that. Now the CPU has two units to store and process data, the control unit and the arithmetic logic unit. CPU is a silicon chip with multiple circuits. And this is known as a microprocessor because literally it is little. Now, multi-core processors are processors that combine two or more CPUs or cores on a single chip. So we can see and we can literally view CPU as the core. And if there are two or more of them, we say multi-core or multi-core. Multi-threading or multi-threading is processing more than one program or several parts of a program at the same time. This is like multi-processing then. Now, This is the CPU as shown on our illustration, what happens inside the CPU in one machine cycle. So we can see here the input devices. If we use the keyboard and the mouse and we input such, then such would be processed, of course, will be accepted by the system and such will be decoded. So what was the instruction all about? Then that's the CU or control unit. Next would be it will be processed to or through the arithmetic logic unit, wherein the process is executed. And of course, that information will be generated into the output devices like printer and the monitor or screen. And of course, it will also be stored on the storage devices. Now, CPU have multiprocessors a while ago. We also have the micro, again, the little ones which are embedded with transistors. Transistor is a semiconductor that can represent binary codes to states. Well, this is again based on machine, but at least we can know. CPU machine cycle is the time period during which the CPU fetches, decodes, and executes each transaction. Going back to the illustration, number one is to fetch such, to decode, to execute, and to store. So fetch, decode, execute, that's the CPU machine cycle. The CPU clock is a special circuitry on the processor that synchronizes all the tasks. So basically it will reconcile, it will coordinate the tasks provided. Clock rate is the number of pulses per second. A machine cycle takes several clock pulses. So if you view this with our body, it's like we have our pulse rate, and then several of the pulses will constitute our respective heart rate or heartbeat rate, right? So the pulse can be combined to become our overall heart rate. So that is the case. In that sense, though, the CPU is like the heart, not the brain. So for this one, we have the computer time, could be in milli, could be in micro, nano, and pico. It's now 1 over something, correct? So milli is 1 over 1,000, micro is 1 over 1,000,000, nano is 1 over 1,000,000,000, and pico is 1 over 1,000,000,000,000. Okay, for the CPU, we have the data word or the maximum number of bits that the control unit can fetch from primary memory in a single machine cycle. For current microcomputers, as of the date of this particular edition, we have current computers or micro, to be more specific, have words of 32 or 64 bits then. So that's actually composed of, if we divide this by 8 bits to become byte or bytes, so we have like 4 or 8 bytes. Arithmetic logic unit is the part of the CPU that performs the mathematical operations, arithmetic and logical. Then computer power, again, as said a while ago, depends on processing speed and memory capacity. Then we have here also the terminologies. If we can notice, we have a lot of terminologies here about computers. At least you will know. Bus would be electronic lines or traces used for communication inside the computer. Throughput, number of bits per second that the bus can accommodate, and MIPS is the millions of instructions per second, that a common measure of computer speed. If we're going to analyze, of course, the bigger these items are, meaning the more powerful the computer becomes, or they are, or is. Now, let's go or proceed to input devices. Computers must receive input to produce output. Of course, that's our basic concept. How can we process something without input? And then we have to make sure, though, that the input or the information or the data that we process and that we place into our computers are accurate or are valid. Because no matter how high-tech the items are, from input down to the last one, output, including the storage, then such would be useless, since the input information or data is or are already incorrect or wrong. So that's why there should be internal control at the onset. And actually that is discussed extensively or exhaustively in other courses like accounting information systems. Input devices would include machines and devices used to enter instructions and data into computer. So these are the input devices, and these are the common ones: keyboard, trackball, microphone, and scanner. We've mentioned a while ago keyboard, microphone, and scanner wasn't, but yeah, just like the barcode scanner in stores, we can input information about the product. So the moment that a certain item is scanned by the barcode scanner through the barcode, then information about that product will be placed into the system, and such will trigger of the information to update in the system in terms of the cash, for example, since normally that is cash or if through credit card or whatever means, but normally those are the items or things, or let's say the purchase order or POs. And then also the number of units available will be updated, and the units sold prior, then sales will be updated. So those items will be updated, and that's a good thing for information systems. For trackball, well, that could be also another input devices that we can consider, but the latter three, or the three that we've mentioned so far, are the common input devices. Now, keyboard is an input device that contains keys that users press to enter data. Well, we all know what keyboard is, hopefully, the ones that we are using for typing, for encoding, in other words. And we can see there letters, numbers, punctuation, and function keys. QWERTY is the standard keyboard layout, but let me just give you this particular insight that there's actually a certain keyboard layout that supposedly would result to much faster typing. However, it's not introduced. So there's like a conspiracy theory about that, like QWERTY is sponsored by a big organization, but anyway, so Dvorak is the option. So sometimes because we're used to something, it's now difficult to adjust to another. We are used to QWERTY from our younger years, and that's why. Now, ergonomics, which is very interesting, is the study of the comfort and safety of humans in the workplace. Like, for example, the posture when we are going to work, especially if we're exposed to computers. Let's say the eye level of us and on the computer, then our posture, again, as mentioned a while ago, the lightings and all, for us to be protected. Health is very important also in our workplace, even if we wanted to make sure that our outputs are generated and our outcomes are achieved. Ergonomic keyboard fits the natural position of forearms, and this would prevent injury. So as said, on the last objective, health is important. Then this one, mouse. Of course, we know this for clicking, whether that's left click or right click. And then we can also point certain item on the screen, just like this. I will be pointing the word mouse. Hopefully you can see that. Then we can also control the screen, and we can also control the information to be flashed. So many uses of that, just like the keyboard. Has 1 to 5 buttons for clicking, locking, and dragging, depending also on the mouse available. Next, trackball. This is similar to mouse, but user manipulates a ball within the device to indicate movement on the screen. So, well, using the ball instead of the respective pointers, just like what I did. Okay, the ball, I'm using the ball. Okay, trackpad, on another hand, is the cursor movement that is controlled by moving a finger over a touch sensitive pad. So just like, for example, using our tablets or iPads. Mice and similar devices can be wireless units, that's true. Although I'm using the wired mouse or device. Touch screen is both an input and output, or an output device. How? If, for example, we inputted information somewhere to keyboard, to the mouse, or to our microphone, and then it is shown there, for example, the information is shown on the screen, that's input. But if, example, the one that we are talking about is what is shown, that's the output, that's the latter one, right? So input is, of course, if it is used for placing information, and then if it is now showing the information, that is going to be output, just to clear that out. Then often used for public applications such as kiosks. This is prevalent in handheld devices, GPS, and mobile phones. Then allows the user to navigate and select by touching the screen. Again, it is both an input and an output. But normally, though, for touch screen, let's say we want to encode or place information, well, for iPad or tablet, so that's input. But if we are now viewing the information again or seeing it or watching it, that's output. Now, source data input devices also are very important because they would copy data directly from sources such as the barcodes, credit cards, and checks. Interestingly, there is a mention here of other input devices or items, which I liked. Barcodes, these are the common ones, but then there are also credit cards, which are being mentioned. The moment that we place that on the system, then certain information will be generated. Of course, with the proper encoding of information like the password or the keys and all, or certain numerical information from the credit cards. But then again, if we place that with the correct item being placed or information being placed, then we can generate information to be placed or will be processed on the system. Therefore, that is an input device. Checks also can be, if, for example, we look at the check and we use that to place information in our system, it can also be an input device. So these three items actually are business data input devices, or business source data input devices to be more specific. Then optical mark recognition devices detect positions of marks or characters. These are also like scanners. They can actually check marks or characters. The OCR devices try to interpret handwritten and printed text. So if mark would be focused on marks or characters, OCR would be on handwritten and printed text. We can also say optical mark recognition as OMR. The MICR, or the magnetic ink character recognition, detects magnetic ink on checks. Now, magnetic strips on credit cards store encoded data. So as what we've said, again, we can use credit cards for inputting information to our system. Again, this is a business perspective. As also mentioned, the barcodes. When we scan the barcodes, information will be placed on the system. It's like no need to physically encode them, as mentioned for the magnetic strips on credit cards. Well, we can view credit cards as an input device, literally, and then part of that is the magnetic strip that helps the information to be placed. Then here is an example of our checks. So if we are going to use MICR, the magnetic ink character recognition, to automate part of check clearing. So we can just make use of the information from here. As said, detects magnetic ink on checks. So this would simplify the operations of the business. All right. So thank you very much for viewing and listening and staying with me of this particular session about business hardware and management information systems. Hopefully you learned something from this session. Thank you very much, and God bless us all.